Alain Dormehl from Microsoft, and he's going to talk to us about innovating with machine learning. Thank you.
Hi, so as I said, thanks Alain Dormehl. I'm a data solutions architect at Microsoft, so I am primarily responsible for big data and advanced analytics workloads, specifically in the cloud space. So I mean, my history, I studied to be a microbiologist. I landed up in IT somehow. I then became a SQL developer, and now I'm an accidental data scientist. So I always like to start my presentations with this video that I'm going to show you now. It sort of shows you a good overall view of Microsoft's vision of where we want to go with advanced analytics and sort of some of the things people are doing in the industry.
The story of human progress is a story of creation. We have, like any other animal, a great skill for understanding our surroundings and inventing ways to survive and then to thrive. We are constantly building on what we know, drawing from it and adding to it over generation after generation, through trial and error, through amazing leaps of imagination and innovation, and also, maybe mostly, through incalculable ages of hard work. Creating new things has never been easy, but today there are new things going on with how companies use data that are changing the dynamic. It is increasingly possible to take massive amounts of data and not merely collect it, not merely process it, but truly understand it inside and out. When you have this kind of certainty about your data and what it means, it becomes a kind of blueprint to the future you want to build for your company. So how do you find certainty in a world where the issues and opportunities are coming at you in real time? How do you find certainty in a world where change is not just inevitable, it is constant? It's not about starting from scratch. It's about taking what you already have to the next level. It's not about cherry picking components. It's about a family of solutions backed by industry-leading research and development. It's about each part being designed and built to work together today and with innovations that are coming through. Give you the confidence you need to start doing more and more amazing things with data. Because when you have absolute faith in your data strategy, then the guesswork and the anxiety are absent. Stop focusing on making the business run and start focusing on where you want your business to go. Certain possibilities are powerful.
Okay. So this seems to be a term that's going around a lot at the moment, and people are talking about data and sort of this explosion of data. Sort of around that topic as well, there's a lot of talk about the different types of data that we're starting to collect now. If you look back to the last 2 years, I think Gartner released a statistic a while ago that said 80% of all the data was generated in the last 4 years. So that just shows you sort of the exponential explosion of data and how important data is becoming, not only in the commercial space, but also in the academic space. There's a lot of research that's being done and a lot of innovation that people are doing in the academic fields that require the ability to process these masses of data, which previously we didn't have to deal with. So if we sort of look at where we are at the moment, and I mean, there's a lot of very industry-leading publications that have come out with the same theory that we are heading into what they're referring to as the fourth industrial revolution. So if you look back historically, in the 1700s, we had the advent of steam engines, and that was sort of what they considered the first industrial revolution that we went through. And then about in 1870, we had the invention of the telegram, and that was also considered a massive change for us. It had a lot of sort of downstream impact on how we evolved. And then more recently than that was the move from analog to digital, and that sort of happened in the 1950s. Now, they're talking about us moving into this era of the fourth industrial revolution, whereby it is being fueled by data, the data that we're capturing, and how we're using that data. So the problems that we generally have are sort of big data is now becoming a very topical thing that a lot of people are talking about, and most people have these masses of data, but they either can't use them or don't know how to use them. So our role at Microsoft is to democratize the ability to do advanced analytics. So you don't need to be a PhD in applied mathematics to be able to run these things. We're trying to make it accessible to everyone. And that goes for BI as well, so the ability to report on your data. If you think back, there are a lot of predictions at the moment whereby 5 years ago when I sort of started my IT career, BI specialists were all the rage. And these were people that were earning sort of a lot of money to build reports, but these were reactive reports. So you always look back historically at what was going on in your organization. Nowadays, when you enter the job market, or at least it's moving towards that, as you enter the job market, your ability to do BI is going to be something that is a given. It's not going to be a specialized job anymore. Same as what when you join the job market, people expect you to be able to do Excel, and they expect you to be able to use Word. They're going to expect you to be able to do self-service BI on your own data, on your company's data, on your academic data for that matter. It's not something that you're going to have to hire a team of people for to do anymore. And then obviously, about cloud has become a very sort of topical thing at the moment, and the big driver behind that is this cloud is enabling you to sort of do massive amount of computation that previously were not possible with your traditional on-prem infrastructure. And then obviously where everyone wants to go is this sort of intelligence aspect here, whereby your data is driving your decisions. And I mean, important to that in the academic sphere is sort of, you know, we want to enable technology to allow people to interact with the environment better. And that is all done through data-driven decisions, data-driven technologies. So, I must apologize, these are very commercially slides, and I've been out of the academic realms for about 10 years. But I mean, you can sort of apply a lot of this logic to what's happening in universities and where studies are going. If you look at sort of the Large Hadron Collider and you look at the SKA that's going to be coming online now, these are initiatives that are driving so much data that we do not currently have technologies that can use that data and control. So that's where this is becoming a lot more topical. And I mean, if you look at the IDC in 2014, they predicted that about $1.6 trillion worth of revenue for companies or academic institutes is going to be available if they start using their data correctly and turning their data into an asset opposed to something that you just kept because it was an auditing purpose. And then they've also predicted that by 2020, all companies, well, 10% of all companies and institutes will have teams dedicated to profiting off their data, to understanding their data. And then I really like this slide, and I think it can actually, it is very sort of relevant as well to the academic realm. 100 years ago, the average lifetime for a company on the S&P 500 was 67 years. In 1980, that had dropped down to 25 years. In 2010, it was down to 15. And they're predicting that by 2020, 75% of the companies that are currently listed on the S&P 500 will not be there anymore. So that means only 25 of them will remain. And this speaks heavily to sort of your disruptive technologies and the companies of the likes of Uber, Airbnb, these companies that enter industries that traditionally they had no footprint in, but they changed the way the industry works intrinsically. A very good example of that as well is the self-driving cars. If you think of the sort of the broader impact that something like that will have in terms of, look just at insurance companies. If you are, as an insurance company, I insure your car against damage. If you are not driving your car and you are not responsible for the accident, what do I insure? I'll have to insure you as the person in the car, not the vehicle, the asset, which is the car. So these are massive disruptive sort of influences that we are seeing globally at the moment, and they're coming in every industry. Massive players who have been around for 150 years will not be here in 30 years' time. And I had a very interesting conversation with one of my customers a while ago, and I said to him, we've been around for 150 years, and we are quite happy with what we do. And we basically turned around to them and we said, what you did for the last 150 years is not what's going to see you for the next 150 years. You need to rethink how you do business. And then these are just some sort of examples. If you look at the Dormehl one, that is a healthcare one. It's a very academically driven sort of case study that's very public to Microsoft. Ultimately, what we did there is we used wearable sensors in the form of Fitbits and these kind of things to monitor high-risk patients, so that we would know before they knew that something was potentially going to happen. We would monitor blood rates, all of these things remotely from a center of call agents that would ultimately be able to respond quicker than anyone in the vicinity of that patient. Another one that I really like is the agricultural one. There's it was sort of an initiative across Israel, which is traditionally quite an arid country, to bring all the data from all the dairy farmers together, and they have this centralized place where they upload all their data and they share it freely amongst each other. So they had run sort of advanced analytics algorithms to understand when is the best time to feed your cattle, when is the best time to give them water the field. And through this sort of collaborative understanding, they've actually managed to get their average yield of milk per cattle higher than anywhere else in the world. And this is from a country that is extremely arid. So that sort of shows you the potential of what is possible using advanced analytics and using machine learning and these kind of things to make a difference ultimately. So if we move along, this slide is in here purely because it just shows you the vast volumes of data that our cloud is capable of dealing with. So if you think about something like the SKA, which will be coming online, it is said to be generating petabytes worth of data in an hour, right? So to manage a petabyte worth of data, you need a lot of compute in the back end, you need a lot of storage. And I mean, our cloud, we've been running on our own cloud for many years. So I mean, we do 300 plus million users a month that do call over Skype for business, and that all runs through the Azure backbone. We have over sort of 48 million members in 57 countries for Xbox Live, and that is all back-ended by Azure Cloud. And I think the most astonishing one, considering Office 365 is actually not that old, is the fact that we basically cater for 1.2 billion customers using the Office 365. And that's everything from document storage through to word processing, to all of these things that traditionally you had to do on your own laptop. And then I included this slide purely because from an academic standpoint, you know, open source is very important. A lot of universities sort of encourage the use of open source software. In Linux is a very popular one for advanced analytics. And that's primarily because they are easy to get into and they don't cost you anything. So these are open source softwares, and this is just a handful of products that we support out of the box on the Azure platform, which you can utilize for big data workloads, for advanced analytics workloads, VMs, anything you want. We have very strong partnerships with people like Red Hat, which is one of the biggest Linux distributions in the world. Hadoop, Microsoft has traditionally had a partnership with Fortinet the last 4 or 5 years. And all of these products are literally one thing that you can deploy from the Azure Marketplace. Any of these products you want. What we see a lot in the advanced analytics space is the use of Docker, which is not here at the bottom on the slide. We see Docker that gets used a lot, whereby you have an environment that you can create multiple times with repeatable results. That's an extremely important sort of criteria when it comes to doing advanced analytics workloads, is the ability to repeat your findings. And then, very briefly, we're going to look at some of the places where we're seeing a lot of traction with advanced analytics workloads. And if you sort of think about how they came to this, a lot of these things originated in academic fields, where people were doing a lot of the research upfront for a lot of these algorithms and a lot of the methodologies that are deployed there. So, if you just look there, predictions is sort of a very big one at the moment, and a lot of people are sort of trying to predict the future. And more than that, we are seeing a lot of prescriptive analytics whereby not only are you making a prediction, but you are taking action off the back of that prediction. So a fully automated system whereby a human doesn't have to continuously interact to sort of get the outcome that you want. So demand forecasting, that's an extremely sort of big problem. It's a very old problem. It's one we've been dealing with for years. And that's basically just to minimize risk. If you think about an ATM, a bank pays interest on money sitting at rest in an ATM. So you don't want too much money in the ATM, but you also don't want too little, because then your customers are going to complain. And then risk and compliance, that one we see a lot. So things like anti-money laundering, anti-bribery and corruption. These are all sort of advanced analytics problems that people are trying to deal with using data. Whereby traditionally, if you look at companies, what they used to do is they used to have policies in place, and you would rely on the good nature of your staff to always be truthful, which, if you're talking about 200,000 staff, might not be the best approach anymore. So, if we look at the third column there, the offerings to customers, this one we see more and more and more and more in the industry. It is about individuals who want a more personalized experience with their vendors. So I'll go back to the insurance example. Traditionally, how insurance gets done is you get bucketed to a segment of people that are similar to you, and your risk profile and your policy sort of payments are calculated based off of this bucket. Now, what it does is it generalizes quite well, and it makes the workload very easy, but it's not necessarily the best insurance policy for you. So what we're seeing now is people are using various different sources like social media, which is open domain data, off the back of Microsoft's LinkedIn acquisition recently. They're using data that's freely available on the internet to sort of augment how they sell you or how they present a product through to you. And I mean, specifically in the personalized offering space, you know, a good example we have is that if you're a customer that traditionally always complains about the same services at a vendor, then what they could do is they could send you a 200 Rand voucher for some generic product that you might not even be interested in. Or they could send you a 50 Rand hat from Chelsea because they know you're a Chelsea supporter. That's sort of where the market is going, because that way they save money. But what they've also done is they've created an emotional connection with you as their customer. And they sell you the idea that they understand you better. And that decreases customer churn, and it increases sort of loyalty to product brands quite a bit. So, in this column here, predictive maintenance, this is one that we are seeing across the spectrum, from anyone who's got manufacturing plants to academic fields of study, whereby people are trying to understand when their hardware will fail before it fails. So if you look at that example, if you imagine a mine that is running a 1 kilometer long conveyor belt, and this conveyor belt generates 10 million Rand an hour, traditionally what would happen is that conveyor belt would run until it breaks, and when it breaks, they would phone the suppliers and they would get the technician out and he'd come fix it, and they had about a 8 to 12 hour turnaround on fixing this problem on the conveyor belt. What they're doing now is that conveyor belt is full of sensors, and they've built an algorithm that understands when something is going wrong before it does. Then what they do is off the back of that, they automatically generate a request for quotes to their top 10 preferred suppliers, so that they can schedule a maintenance window of 2 hours opposed to 12 hours. So they save money and they increase their productivity. And ultimately, if you think about that across sort of any industry, that's an extremely valuable thing to be able to do, because minimizing downtime is an extremely important thing in sort of any kind of sphere that you work in. And then we're not going to cover that because that one's big business. So these are sort of the big industries that we're seeing a lot of work in at the moment. Retail obviously has traditionally extremely big sort of customer that requires these kind of things. Sentiment analysis is one that we've been doing for years. So it is understanding the intent of a message. So is someone angry at you or they're happy with you? And through that you can actually do a lot of different things. We've got a very example that we'll go over a bit later with sentiment analysis specific. But manufacturing ops, you see there it comes up again. And that connected car one, that's what we were talking about earlier with these self-driving cars, whereby the car manufacturer is actually the one person in the world that knows more about your car than you do. And definitely the one person in the world who knows more about your car than your insurance company. So why are they not using this data to help the insurance companies do better jobs and to understand the roads better? Because if you think about South Africa, traditionally we have potholes are quite a problem here. If you could gather data from all these cars and you understood how to classify when a car drove over a pothole, that information could be used by government to know where the potholes are. Without someone having to phone them, without someone having to tell them there's a pothole in an area. Risk assessment and customer experience, we've spoken about those, and then these remote health monitoring and population health management. Sort of going to that Dormehl Hitchcock example that we went over. And then just the last one here, sort of with the government sector. Smart buildings is becoming a really big thing. It's becoming a worldwide thing. It hasn't really come to South Africa, other than the sort of if you drive down the N1, you have F&B's building on the one side there. That's probably one of the best examples we've got of what a smart building at the moment. But that whole building is, last time I checked, it wasn't 100% self-sustainable, but it is almost there. And this is a very topical thing. I mean, it's government is talking about it, financial institutes are talking about it, universities are talking about this. The transit and traffic optimization. So I mean, if you think about how long you sit in traffic every day, if you could make that a little bit easier, everyone would appreciate a service like that, and it really wouldn't take a lot to do that. So, why the cloud, right? That's sort of a big question that we get asked a lot, and advanced analytics, where it is today, is in terms of the stats that they run and the algorithms that they run, that stuff hasn't really changed much over the last 10 years. There have been new algorithms that have come up, but the basics and the sort of the underlying knowledge that fuel stats and sort of advanced analytics, machine learning haven't changed. What has changed is the amount of data that we now need to use these products on. So the cloud offers you sort of speed to market. So we always say that, like, gone are the days where you would sort of go into this 2-year procurement cycle on a new server and with lots of POCs and things like that. We're now looking at a cycle whereby fail fast is sort of the order of the day. So you can create something, you can run something, and if it doesn't work for you, you just turn it off. And that's the end of it. Move along, try something else. That's the whole point. Speed to deployment is really important here. So stop trying to procure these $1 million servers where all of that can be done in the cloud, and if you fail, you fail, and that's it. That's the end of it. Whereas with traditional IT, you're sitting with this piece of hardware for 3 to 5 years, and you have to depreciate this sort of asset over a long amount of time. And then scale. Scale is probably the biggest compelling reason to move to the cloud. Scale is ultimately what is driving the motion to the cloud. Whereas if you look at the CSIR, what it was about 2 months ago, they launched their new supercomputer. If I'm not wrong, it was running 40,000 cores. That's a fairly sizable machine. It's a massive investment that someone's made. The problem with that supercomputer is the fact that if you as a research agency want to use it, you have to book time 6 months in advance. So you can imagine if you're in your PhD and you're trying to get into this thing, you have like these 6-month windows where you can run data and it's really nice, and then for 6 months you do nothing. Well, you kind of, but you don't do what you're supposed to. Now what the cloud is going to give you is, if you look at one of Microsoft's data centers, they sort of get built in like pairs and pods and things like that. We run hundreds and hundreds of thousands of CPUs per data center, and they are there for you to use when you need to use them. So if you need to run a high-performance compute job that requires 40,000 cores, we've got 40,000 cores for you. You can run your job and you can turn it off, and that's the end of it. You don't have to continue having that asset and continue investing into that asset if you're not using it. So it is, as I said earlier, it is basically democratizing advanced analytics and sort of the ability to report on your advanced analytics. If you think of the amount of compute that's required for you to run a 3D simulation, those are massive computational powers. The cloud has the ability to compute three-dimensional models, whether that is using traditional cores or whether that is using graphics cores. Both are available in the cloud. And then obviously economics. Economics is really important. So why this is important is because in the cloud, if you had to run a job that took you a day, you would run it for a day and you would turn all the underlying infrastructure off, and that would be the end of it. There'd be no charge after you turned everything off. Whereas again, with your traditional IT, you purchase a server, that server has to sit in your server room for 3 to 5 years as a depreciating asset, whether you're using it or not. So if you think about a server that you just bought, it costs you 100,000 Rand, and that thing over its lifetime runs at 50% capacity, that means 50% of your investment was never used. So this money was going away. So now we look sort of at where everyone is moving in the advanced analytics realm, right? So data, that's where everyone starts. Everyone has data. It's understanding, it's interpreting, it's doing something meaningful with that data. That's where sort of the real value currently is. So traditionally we have this sort of approach whereby you have data, you run a static report, and then there's a manual process off the back of that which then drives a decision. And that's sort of the what happened phase. So I'm looking backward on time and I'm saying, okay, this is what happened back then. Let me think and come up with a plausible sort of execution for this not to happen again. But that second part of the equation is not a data-driven decision. It is a me as an industry expert-driven decision, and I might get it wrong sometimes. Chances are I'll probably get it wrong 50% of the time. And sort of this is what I was speaking about earlier with the interactive dashboards, whereby if you enter the job market nowadays, it's expected of you to be able to do Excel. It's expected of you to be able to do Word. That's why all universities, I mean, even when I was in university 10 odd years ago, computer literacy is not, it's not a subject you've got a choice to take. You have to take it. Everyone has to take it. It is sort of where everyone is moving at the moment. So this ability to run basic reporting and basic analytics on top of your data is becoming a more and more increasingly important skill for everyone to have. And then we move sort of into this realm where a lot of people are moving towards or are currently sitting, whereby you want to do predictions. So one of the best examples I have of this is in the Seattle Bay area, they've sort of put a lot of sensors in the ocean and they try and monitor the acidity levels in the ocean. Because they grow a lot of oysters in the Seattle Bay region, that acidity affects the growth of the oysters. So what they've now been able to do is they've been able to build predictive models on top of sort of three-dimensional fluid dynamic models to predict how the acidic water is going to move through the Bay Area so that the oyster farmers can go move their crops out of the way. So these are sort of the places where people are trying to go. This is where everyone wants to be. If you look at fraud traditionally is what anomaly detection. So you look at transactions and you pick up, okay, this one is anomalous, it's out of line of what someone traditionally does, so it has a high probability of being fraud. Problem with that sort of model is the fraudulent transaction has to already have taken place for you to know that it's fraudulent. Ergo, the money is already left. So what we're seeing a lot now is people sort of behavioral predictions to try to figure out, is it actually you sitting behind the computer? Or is it actually you that's using your cell phone on internet banking? And if it's not, we can pick up before the financial transaction that something is wrong, send you an OTP, block your account, phone the customer, whatever the case may be, but stop the money from leaving the bank. The minute the money leaves the bank, it's a really difficult process for you to go through sort of auditing, forensics, and all of this stuff just to get to a point where you as the consumer were inconvenienced to get your money back. And then sort of where everyone, sort of the utopia of advanced analytics at the moment is these recommendation engines, whereby off the back of these predictions that you're doing, you make decisions to support the prediction, and these decisions are automated. So if you think back to the fraud example we just gave, we pick up that there's a high probability that this is fraudulent user using the product. Don't wait for a call center agent to get a notification and phone you and then find out it's you. By that time, it's too late anyways. Block the account, send an OTP, contact the customer. Do all of that for me, and then I'll speak to the customer. But look after him first, and then we'll move along from there. So ultimately what you want is you want sort of these self-actioning systems that can do a lot of this for you without you having to sort of monitor them and look after them all the time. So this is just sort of an overview. You know, traditionally we were very reactive in this space, and we're trying to become extremely proactive in this space. We used to look historically back at our data. Now we're predicting what our data is going to be forward. And then obviously people and processes were always the traditional way, you know, this looks like fraud, let me phone my customer. This looks like fraud, let me block his account just in case it is fraud. One has a much more positive outcome than the other one for an end consumer. Now, this is sort of being used in a lot of places. If you look at how they do mining simulations, they sort of build this simulation of geographical information. But it is still only, it's a prediction. It's not 100% because they sort of build an algorithm that understands if this looks like that and they have these sort of measurings, then there's a very high probability that there'll be gold over there and things like that. They get it wrong a lot of the times. But that's still a predictive methodology. It's a way for you to be able to say, with a fair degree of certainty, that you think that there is an outcome that is favorable to you in that scenario. So ultimately, what Microsoft is doing in this space is sort of offering a platform that is going to make it easy for you to ingest your data, do your data munging, so like your data cleaning and your data ETLs and your feature samples, and then run the advanced analytics. And all of this is done for you at scale. And we store this data, we persist this data in sort of probably some of the most secure data centers in the world. We have government divisions from the US, from the UK, from all over the world that are using our cloud, because ultimately we have invested so much time and effort into this that this is Microsoft's future. We have to go this way. We're too far down the road now to turn around and say, no, we want to start selling licenses. That's never going to work for us as a business model. We need to start embracing customers that have on-demand requirements, not sort of these very delayed things where licenses for a server that I might acquire in years' time. And then sort of leveraging the advanced analytics, we have the ability to, because of this unlimited sort of compute and memory and storage pool, which is fueling all of these tools, we have the ability to do insights on data sets that were previously unthought of. And if you look at how we traditionally did statistical analysis, we would take this data set of 1,000,000 rows and then we would say, yeah, that's never going to run because I don't have enough memory for it, so I'm going to sample it down. And then that's a good way to do it, but the problem with that is by sampling down, you sometimes get a model that doesn't generalize well with the full population. So then you waste time. So now you spend 2 months building a model that generalizes terribly over the full population, and then you ultimately back at square one. In the business world, that means your boss is standing here going, why is this not finished yet? It's not a case of, let me just quickly fix this. But now, because of all this compute and this sort of the ability to crunch these masses of data, those problems are sort of going away. They don't exist anymore, which previously they did. And then obviously a lot of the things that we're doing in the cloud, a lot of the products, a lot of the platforms that we're offering in the cloud, specifically in the advanced analytics space, are sort of making it easier for us to automate these processes. So less human interaction. So, I mean, if you look at traditionally how we did our statistical work, a lot of the work was around ingesting data and doing data cleanup. That's 80% of your job, is that. You don't need to be a statistician to do that, but the fact of the matter is that is the bulk of your work. The actual model building and the nice stuff is probably only about 20% of what you realistically do in your job every day. So we're trying to make that easier. We're trying to make that an automated process whereby you have less interaction with that process and you build it once and it will run for every day. And then, sort of more recently than that, Microsoft has released a lot of what we consider these cognitive services. So as I say cognitive services very lightly because cognitive services implies that you have an understanding of the whole picture. So a very good example of that is a while ago, one of the other sort of machine learning vendors put out a publication about how they read 800 million pages on Bob Dylan's life, and they sort of came up with this one-line sentence about how all of his music and his sentiment was about love and peace and death. And then everyone sort of turned around and said, no, I don't know if he actually lived in the 50s, but Bob Dylan was actually about anti-war, fight the system, that kind of stuff, not really love and peace and all of that. So even though the algorithm was successful and they were able to ingest these large amounts of volume, nothing about what they did was cognitive because their system didn't have the ability to understand the whole picture. It had the ability to do traditional sort of text analytics, count the words, count how many times they come up. Like that stuff we've been able to do very long, but there are certain services in the cognitive space that we're quite comfortable with, like the biometrics, the speech to text sort of analytics that we've seen a lot of, and then natural language queries. That's an extremely big one that's taking off a lot now, and that goes again hand in hand with the BI that we're democratizing into every organization in the world, whereby you can type a sentence on your computer and you can say, show me sales forecasts for June. You don't have to be able to write the code to do that. The system is clever enough to understand the intent of your question, and it will go generate that report for you. So then just very briefly, not going to spend a lot of time on this, but this is sort of what Microsoft has in the cloud at the moment. We call it the Cortana Intelligence Suite. So it is a set of products that we've put together to make advanced analytics and data analytics workloads easier for everyone. And we've covered everything from the information management portion, whereby you have products like Event Hubs that can do ingestion of real-time streaming data without you having to persist the data, or something like Data Factory, which allows you to build complex ETL jobs from data that's anywhere. That data could live here, it could live in the cloud, it could live at a remote site in Sudan. As long as they had internet, you would be able to use data factories to bring all of those data sources together, massage them a bit, and then put them in a database for you to use. And then sort of the big data stores, this is what we traditionally talk about these, SQL, Microsoft big SQL for many years. It's sort of one of our flagship things. But SQL is now launched into Azure, and it's no longer a case of you have to sort of install your own SQL, have licenses, and all of these things. These are all managed services. So these are platforms as a service. So you create a data warehouse. You don't have to worry about the server that it runs on. You don't have to worry about any of that. We provision all the underlying infrastructure for that platform to run on top of, and you just utilize the end product. So you don't need a dedicated database administrator or a dedicated database sort of security architect. You just create the data warehouse, and everything else is taken care of for you on the cloud. And then in the analytics space, we've sort of got machine learning and a couple of others. We'll go into those in more depth now. And then obviously the intelligence section, I've also got some slides coming up on that. And then very important is the dashboarding and visualization. Without that aspect, all of the other stuff doesn't matter. Because if you can't visualize and show someone else what you have done in a meaningful way, none of it actually matters. Because no one wants to sit and look at tables and tables worth of data and sort of come to their conclusion. Nowadays, people want to see small, quick, concise infographics that tell you everything in one page. Not reports on reports on reports of data that no one is actually going to read. So here we're going to very briefly cover sort of some of the products that we offer out of the box. So this is Azure Data Lake. So Azure Data Lake is sort of one of our new flagship products that we are hunting, that we are sort of very proud of at the moment. And it is ultimately a data store for any data. Unlimited size, unlimited type, unlimited velocity of data can be stored in Azure Data Lake. And that's everything from device data through to social media. We've got clickstream data, which is where we see a lot of sort of the behavioral analysis that's coming into things. And then obviously the new buzzword for everyone is sort of Internet of Things, and that's for your sensor data. So Azure Data Lake is ultimately a data store that will take any type of data and give you the ability to run an analytics workload on top of that using products that we're all familiar with. So if we look at that portion, this is sort of the computational element of it. So the data lakes analytics, it uses a language called SQL, which is a sort of a C# and a SQL combination, but it allows you to run advanced analytics functions across data of any type in one place. So imagine you had speech data and video data and X-ray data all living in the same place. You could run an analytics workload across all of them at the same time without having to sort of first extract the value from the data and all of these things. So I'm going to go quickly. Just gave me a notice there. So stream analytics, that's the ability to run analytics on data in motion. So you can, without traditionally in stats, you would have to go persist your data. Once it's persisted, you would run an analytics workload across it. Stream analytics now gives you the ability to do that real time with data in motion. You do not have to persist the data. The reason this is important is because you can do ultimately analytics workloads that have to have real-time responses. Think back to the fraud example, it doesn't help that there's a 5-second delay on you predicting fraud. You want it now, you want it milliseconds time. And then obviously machine learning, very important one. So we've sort of built a simple, scalable solution that is very intuitive. It has 72, last time I checked, 72 algorithms that you can use out of the box. This is everything from neural networks through to decision trees and basic regressions. All of these are here for you to use out of the box. You do not have to sort of write them yourself. But we've also given you the ability to ingest native R code or native Python code. So if you can write your own algorithms, then do it. We don't stop you. The beauty of that is we can do it here, and you can sort of use the scale and the compute power that fuels Azure machine learning on your own code. And then just very quickly, we could go over sort of some of the cognitive services that I was talking about. So there's everything from emotion detection of videos through to sort of recommendation engines where Amazon is kind of running every day, all over the place. The bot framework, I'm just going to rush through my last two slides. The bot framework is basically a bot that has the ability to understand the intent of a message. So if you think about call center, it's very frustrating. You phone the call center, and the call center says to you, no, like, yes, you must push 1, and then you must push 2, and then you must push 3, and by the time you push 3, you're at the wrong person. And then you start from the beginning again. These bots will have the ability for you to tell it what your problem is, and it will figure out where you must go. And then, just sort of the very last one we'll look at here is the Cortana suite, which is your personal assistant. So that is your sort of, if you look at Apple was Siri, and then Cortana is always your Microsoft one. The difference here is that Cortana actually runs self-learning algorithms. Siri is sort of I'm not saying she's static, she does learn, but not to the scale that Cortana does. A very good example that I always like to use is Cortana knows it reads my emails on my computer. It doesn't read, but it understands my emails. And she knows when I'm traveling. So 2 or 3 days before I always go on a business trip, I sort of get a notification in Windows that says, oh, I know you're going to Durban tomorrow. Would you like me to book a hotel? Would you like me to book a car? That's sort of where the personal assistant experience is going. With us as Microsoft are trying to do. And that's where we'll end. Yes. Yes, I will. That's Microsoft. That's right.
Thank you.